revolving around applying microscopy, scanning electron microscopy, energy dispersive spectroscopy, SEMEDS, cathodoluminescence, I'm not sure how to pronounce that, but CL, and then X-ray fluorescence, XRF. So welcome, Thomas.
All right, well, thank you for organizing a ring circus, and I'm excited about everybody in here for this talk. Okay, and my talk is technical study of John Farge, is Peacocks and Peonies 1 and 2. So these are the objects we're talking about. They're fairly large objects, 112 inches by 51¼ inches and 6½ inches thick. So they are a pair of windows, and John Farge had done these for Frederick Ames Boston House in 1882. During this time, there's revitalization in stained glass in America, and Farge is actually a painter, and you saw this as an extension of his painting work. And it's very interesting because his materials are very experimental. So when we say experimental, we mean like glass plating, glass, cast glass, so fractured glass jewels, so a lot of different things. So this information was provided to me by Madison Whitesell, who worked on this, and she got to work on this while the object was being moved to a new permanent exhibition. And through conservation, they discovered that there was glass alterations on specific colors. And this is how I got to meet Madison. She asked me, what's the composition of this glass? I was like, and this is a purple XRF spectra. There's a lot of peaks, and we're looking at it. And having worked in this problem before, it's actually a tricky one because in the absence of vacuum, atmospheric scattering from air will result in additional lower yield of the lower energy characteristic X-ray lines. So my colleague and I had been working with Booker on a collaborative project where we actually were collecting data to better explain this. So the top left here, this box, is a set of single crystals that we used with those specific elements of interest that yield those characteristic X-rays. When I say characteristic X-rays, I mean they form a peak. That's the peak that we're going to be chemically identifying by. And Brooker had an instrument that could collect XRF at atmosphere, and it could also pull partial pressures of 2 millibars, so we can get a better vacuum. So to visualize this, it looks like a very complicated plot, but let me explain. So the x-axis is our energy in keV, so kilo electron volts, and this is where we would expect to see an iron peak. And when we say vacuum enhancement, that it starts at 1. So 1 to 1 would be we lose no signal, right? So when we actually move down here, potassium and calcium, we see a little bit of difference. Now, we're mainly focused on the beryllium window, the diamond shape. So, because our detectors have beryllium windows. But as we move for energies that are below 3 keV, so the characteristic energies here, you notice that for silicon, it's actually, in vacuum, you get 19 times better signal than in air. We want you to remember this number, and as we try to evaluate things that are even lighter than silicon, like aluminum, magnesium, and sodium, you can understand why we may not see those peaks in purple XRF in air. So this would require, this is shown 850 times better in vacuum than in air. So, okay. Being that the object can't fit in SEM, we can still get a sample, and just by taking the sample and putting it in SEM, we can do backscatter electron imaging, and you get a size scale. It's small. It's on the millimeter slash sub-millimeter scale, and not a lot can be seen. It has pretty, other than some particles and stuff. When we map, we get the EDS data off of this, so the characteristics for sulfur. We have a hot spot here, and that gray spot, this is the extracted spectra from there, and we find that there's sodium sulfate. And in comparison to the rest of the composition, we actually have like a glass composition, like it contains sodium, silicon, and some other elements, but we can actually still learn more than just analyzing the surface. So similar to paintings, we published this paper early on when I joined MCI. Basically, we found that like this was Jason, my colleague, liked this technique because she didn't really need lab supplies to do it. You could, and a lot of people read this paper during the pandemic because you could do things at home. But basically, it uses takes advantage of the fact that we use these things called basically you buy them from Superium that are called restickable dots. So this dot you stick down the painting and paint cross section, and you use either a bioplastic or resin, and you form a mount. And what happens is the stickable dot doesn't wet with the rest of the epoxy, and you can peel it right off. So nothing submerges. So your polishing becomes a lot easier. What's actually really cool about this is that for sub-millimeter or millimeter scale glass or porcelains, it also works. So we can actually generate cross sections where we can actually get data about the microstructure of the glass. So this is that. So this is the diffuse light from the high rocks, and this is the reflected bright field. So I basically polish until I see, like if there was anything submerged, like it wouldn't show up in the reflected bright field. So when I say reflected bright field, this is basically what high rocks called coaxial. And with this cross section, we can actually see BSE contrast. So we can see atomic difference. So that atomic difference is basically sodium. There's a patch of sodium within this higher concentration of silica around it. And we can visualize this, and now we can do something called SCM EDS standards-based quantification. Now, basically we've written a paper about it where we use standards for basically all the major elements, and we have intensity scales to figure out what the concentrations are. When we do it this way, when we come up with a low total of like 92%, that's actually real. It means that you're missing like data for water, so like basically glass alteration. So that we can confirm that the surrounding orange visualized silicon-rich region here of like 83% silica and 4% sodium is the altered glass, and the unaltered glass is actually the center here, is an 80% silica, roughly 80%, 19% sodium glass. And there's not much of anything else in there. There's everything else is 1% or below, and it ends up being that you may be like, so there's only sodium and silica in this glass. So like in my training in ceramics, you can actually buy dispersants that's called sodium silicate. So that's how dispersants basically work, by like basically dissolving in water and suspending your clay raw materials. So if it's that prone to glass degradation in that form, it is likely very not stable. So in our SCM, we have a micro XRF on it, and what we can do is we can also get data from that, and we see a lot of the peaks, the same peaks that we had seen before. And this is the previous plot from in air. I want to point out this peak is about 60 counts there. Well, it's 60 kilocounts, and when you divide it by 19, you are down here. around 3. So what we saw around here with the lead silicon being 1-to-1 ratio in portable XRF, and you would assume, is this a lead silicate? No, it's this is how we get a more 1-to-1 scale of the peaks in explained. My colleague Erin Birdsall then provided us the Raman data. So this is another non-destructive technique that can measure the molecular vibrations to give us the molecular signatures. First, she did it on the surface as is before we embedded it, and we can detect the lead corrosion, which was lead carbonate, and then she can also see the glass. The glass is this blue spectra here, and when we did create a cross section, we were able to see this brown spectra here, the additional piece of silicon, oxygen, silicon stretch, and the silicate networks to confirm that it is consistent with what is reported in the literature for a monovalent class. So monovalent being sodium silicate. Sodium has +1. Okay, so in conclusion, so though there's limitations to what we can fit into an SEM or EDS, we can generate sub-millimeter cross-sectional samples that can help us visualize and quantify altered and unaltered glass compositions. And Raman, in this case, provided us confirmation of the precipitates and information about the structure of the bonding if we analyze the glass the actual polymer glass sample. Additionally, MCI is working to provide, looking into providing portable Raman capabilities. And the final conclusion is a lot of my work revolves around, but I'm lucky in that I don't just have an XRF, I have an SEM that's pretty close to XRF. So we find a lot of our research that SEM EDS is very, very complementary to XRF data and can help us explain a lot that can often be confusing. And that's it. Okay, we have applied the sub-millimeter embedding technique to create cross sections for porcelains, and also if you want to learn more about how we quantify glass alteration in the SEM EDS with the standard space technique. This is a paper that we wrote up. I guess we'll have field questions.
I think we have time for one
really?
question.
Oh, okay.
Yeah, no, you're running a little ahead.
Oh, okay, well, that's great. Hopefully I didn't talk too fast.
How many places did you do the analysis? Because the objects looked like they were very large.
Oh, so like they only brought me the one sample. So if it's possible to do more, we just didn't have more samples. So, yeah. But it was part of their visit, their internship program. So.
What was it about that area that?
Oh, they wanted to first know what the composition was.
Right.
And we saw that it was like.
Was the color they were after, or what?
Well, the color, yeah, a little bit about the color. I mean, it's like I didn't get a lot of the field notes on that. I think they wanted the major composition on that, but I presume that the color was probably there is a little bit of copper that probably could have given the color, details there. Well, there's probably coloring, but that wasn't their question. They wanted to know what glass is this and how it's thick. Just get a familiarity with how badly is it going to degrade.
Is Patricia Patty Favero, and she is a conservator at the Phillips collection and is responsible for study and treatment of paintings dating from the mid-19th century to the present. At the Phillips, Patty has carried out in-depth technical study of works by George Baroque and Pablo Picasso, among many others. She holds an MA in art conservation from SUNY Buffalo State University.
So I always want to cover change. I'm just going to jump right in. Recently, paintings at the Phillips collection by Mark Rothko, Milton Avery, and Adolf Gottlieb were examined in support of an exhibition looking at the close friendship and working relationship of these three artists. 13 works by Avery and 2 by Gottlieb were examined, in addition to the 4 paintings that make up the Rothko room at the Phillips, which are the focus of this presentation. The Rothko room was the first of its kind to be devoted to the display of Mark Rothko's paintings. However, the 4 paintings that make up the Rothko room, which date between 1953 and 1957, were conceived by the artist as individual works rather than as a group to be installed together. Between 1957 and 1966, founder Duncan Phillips worked with Rothko and his dealer Sidney Janis to realize the first permanent installation of his work in a museum. Phillips first exhibited Rothko in January 1957, together with Bradley Walker Tomlin and Kenzo Okada. The exhibition was installed in 2 small galleries of the old Phillips mansion, where one room was reserved for the display of 6 paintings by Rothko. Paintings by Tomlin and Okada shared the other space. From this installation, Phillips purchased green and maroon. In a letter to Sidney Janis the following year, Phillips wrote, "I often wish we had room for another Rothko. He wears so well and is definitely an artist after my own heart." In May 1960, Phillips mounted a solo show of 7 paintings by Rothko in the same small galleries of the old mansion. Green and maroon was featured, and from this installation, Phillips added the paintings Green and Tangerine on Red and Orange and Red on Red to his collection. Even at the time of this exhibition, Phillips was already making plans for a permanent room devoted to the artist. That year, he was building an addition to the old mansion with larger spaces to accommodate larger paintings. Plans for the building also included a smaller gallery measuring 13.5 feet by almost 24 feet. In the fall of 1960, the new building opened, and green and maroon, green and tangerine on red, and orange and red on red were installed in this space. When Rothko visited the museum the following January, he was pleased with the installation, but suggested more diffuse lighting and the addition of a simple bench in the center of the gallery. In communication with Rothko, Phillips added ochre and red on red to his collection in 1964, again through Janis. And after some adjustments to the gallery space, Phillips saw the 4 paintings finally installed together 2 years later in May of 1966, shortly before he died. Even while the presentation of the permanent collection at the Phillips changes frequently, the Rothko room has remained constant for 60 years with few interruptions. With the 2006 expansion of the museum, the Rothko room was relocated to the new building, but retains its original orientation, proportions, lighting, and layout. Excuse me. For this study, because of space limitations and to minimize handling, the paintings were examined in the gallery on Mondays when the museum is closed to the public. Each painting was examined under natural light and with magnification. Paintings were also viewed under ultraviolet illumination to look at visible fluorescence. UV imaging was carried out in the darkened gallery space, but visible light could not be completely eliminated, so images showing visible fluorescence also include some visible light. The paintings were also examined using reflected infrared imaging. Observations were compared with other published studies and supplemented with notes and images from previous examinations and treatments found in our files. In general, Rothko's working methods for the Phillips pictures appear consistent with other published accounts of his work. Even while these limited examinations add to our understanding of the Rothko room paintings, they also raise new questions for future research. So there's more to do. So after a lot of introduction, here are a few technical notes, beginning with the painting supports. Orange and red on red, third from the left, and green and tangerine on red, second from the left, came to the Phillips stretched on conventional fixed strainers with 2 crossbars. Green and tangerine on red has since been restretched onto an expansion bolt stretcher sometime between 1970 and 1987. Ochre and red on red at the far right was received stretched on an early version of a continuous tension stretcher. Each painting is signed on the reverse, mostly in paint. A label from the Sidney Janis Gallery is found on the stretcher for ochre and red on red and seen in the photo of the original strainer for green and tangerine on red. The strainer for green and maroon is of interest because it resembles published descriptions of Rothko's working strainers. The strainer bars for green and maroon are rough and narrow with a deep inside bevel to minimize canvas contact with the inside edges during painting. The strainer is stabilized at top and bottom with cross members attached on top of the strainer bars. So, hey, it works. This detail image shows the strainer crossbar at the bottom, viewed from the side. A central horizontal crossbar was once similarly attached across the center on top of the left and right strainer bars, again to minimize contact with the crossbar during painting. This central support was removed before the painting came to the museum. Without it, the strainer would torque as the canvas reacted to periods of low relative humidity. This is in the early days before we had our HVAC. A new crossbar support, the one seen in the image, was added in 1998. The canvases appear to be prepared with a thin, transparent colored priming that extends to the tacking edges and is left visible in other areas. This is consistent with descriptions of Rothko's use of rabbit skin glue mixed with dry pigments applied as a stain and sized to raw canvas. However, this layer does not appear to stain through the canvas, while other colors of the composition do. So this is an inconsistency that we'd like to clarify with future study. The red priming of green and tangerine on red has faded over time. Hints of red seen along the tacking edges, which had been covered with tape since a 1970 treatment. I don't know if you can see it, but there's a little bit of red here and here. And the white is residue from the tape covering the tacking edges since 1970. And this provides an idea of what the original background color might have been. Retouching from a 1985 treatment applied along the edges and in a large area at the center left edge gives a hint of the background color as it would have appeared in 1985, when it was likely already somewhat faded. So this study's findings underline the importance Rothko placed on proportion and the consideration he gave to the balance of forms in addition to color relationships. In the book, Duncan Phillips and His Collection, Marjorie Phillips recalled a visit to Rothko's studio where Duncan asked the artist, quote, "Am I right in that your approach to your work, color means more to you than any other element?" And Rothko answered, "No, not color, but measures." And by measures, I think he meant proportions. So the infrared image of green and maroon reveals that the lower maroon field was initially divided into a narrow upper band, here, and a smaller rectangle below. You can just make out a suggestion of this division in the visible light image, sort of here, where there's a slight difference in the surface and the straight edge near the top of the red field. Close examination finds hints of color at the edges of the form that suggest the original color scheme may have been a narrow band of orange above a field of red. It's very difficult to define layers, but one scenario might be that Rothko painted over both the red and orange shapes with a thin blue layer and built up thin successive layers of red, blue, and the blue-green color, eventually achieving the final maroon color. These changes translate to a relatively thick area of paint in the lower field, along with raised cracks seen in the raking light image that sometimes result from the compositional changes. By comparison, the upper green field is painted sparingly with a thin stain of green and thin black washes. There are also tiny irregular metallic particles, maybe foil or mica, which are seen as white dots in this close-up image. And these are also embedded throughout the green layer. Another significant change in proportion was found in the infrared image of green and tangerine on red, where a clearly defined rectangular area in the upper field suggests Rothko initially meant for this field to be smaller. The upper border of this initial shape is suggested by Pentimenti in the visible light image, but it is completely hidden in the ultraviolet image. Rothko's enlargement of the dark green field may have been merely for visual balance, but it's hard not to see some significance in this change with regard to his description of the painting, as recalled by Marjorie Phillips. She says, Rothko said that the striking tangerine tone of the lower section of the canvas could symbolize the normal, happier side of living, and in proportion, the dark blue-green rectangular measure above it would stand for the black clouds or worries that always hang over us. Examinations also found that Rothko considered the balance of his compositions from different angles while painting. Drips of paint flow opposite to the hanging orientation in both orange and red on red and ochre and red on red, suggesting that Rothko inverted both canvases at least once while he was working on them. In orange and red on red, orange drips flow upward from the bottom of the central orange field. The drips are very subtle. You can kind of see them here in this angled photo. They may be in or just beneath the surface layer. It's very difficult to tell. And along the top border of ochre and red on red, ochre drips flow upward from an underlying layer in the ochre field of color. In this close-up of the top edge seen under ultraviolet, the drips fluoresce while the surface layer does not. This implies a use of different binding media in these two layers. In the upper field of ochre and red on red, variations of the ochre color can be seen at the edges of the field and hint at Rothko's process of layering multiple hues in the search for his desired final result. A tiny paint loss in this field opens a small window into the highly pigmented surface and reveals bright yellow and pure blue color beneath. With this revelation, combined with glimpses of a greenish layer at the lower left corner, one might speculate if Rothko layered yellow over blue in his search for the final hue. This seems drastic, but more study would be needed. It was outside the scope of this project, but future examination of a paint cross-section from this area of loss may offer more insight into Rothko's development of this picture. Hints of Rothko varying his paint media are also found in orange and red on red. Subtle but significant differences in paint characteristics are found in different areas of the composition, from a slightly glossy, cohesive surface of the narrow red band at the top of the picture to a highly matte, underbound surface of the central orange field. Variations in visible fluorescence under UV also indicate Rothko's use of different binding media. Notably, the surface of the central orange field does not fluoresce, but underlying layers seem to glow through the surface layer, and there are brighter fluorescences where these layers are partially exposed along the edges. In this detail of the lower right corner, there appear to be maybe one or two layers beneath the surface. But when viewed in UV, and I apologize, I don't have a detail of the same area in UV, but the fluorescence tells a different story. In particular, there seems to be a colorless layer. There's an area here that's relatively glossy on the very matte orange surface that in the UV fluorescence image, you can see like a little dot of fluorescence in that space. And that same color of fluorescence can also be seen along the edges, along with other colors of visible fluorescence. We can't speculate on the types of media because of the visible light component of the UV images, but it is still of interest in assessing the condition and structure of these pictures. And it makes sense that by varying his media, Rothko could hope to avoid disturbing underlying paint as he built up the thin, colorful layers to achieve his luminous surfaces. And finally, some infrared imaging of the canvases offers a glimpse into different ways in which Rothko applied his paint and may warrant and does warrant further study with higher resolution imaging. For instance, in this detail of the infrared image for orange and red on red, this shows a measured application of relatively thick paint up here along the narrow band at the top and using short vertical brush strokes and a wide flat brush. And by contrast, in the lower portion, I'm not sure if you're going to be able to see this. It's very subtle, but in this picture, almost liquid paint appears spontaneously applied, perhaps mopped or sponged onto the surface. And if you start at this upside down drip and move your eye down into this area, you might be able to see sort of this, it's almost like a dirt pattern of splattered. It's unclear where this is in the paint layering structure. And the infrared image for ochre and red on red reveals horizontal brushstrokes beneath later vertical strokes through much of the upper field. I was kind of surprised to see this. And this is a close-up. You can see the horizontal brushstrokes, the vertical, and then in the darker area in the upper right, it's a different and less definable manipulation or application of paint. So another question for further study. And that is all I have. I'm very grateful to my colleagues at the Phillips Collection for their support and to all of you for your attention and any observations or questions you may have. Thank you.